Hello, I have some components to sell that I think you might be interested in if you're building a helicycle. I don't need them anymore, and I'm cleaning out my garage and my workshop. The first is an unused Bose noise canceling Aviation X helicopter headset. I had two, but I've already sold the one on the left. These are unused, but they've been sitting around for years. I can't remember why I bought three of them. I used one when I was flying, and I had these two set aside to sell to friends, but I never got around to it. So in the intervening years, the ear cushions deteriorated. That's the only thing that I noticed that didn't look brand new. So I called Bose. It turns out they have a refurbishment kit that they sell for this headset, which is due to arrive tomorrow. And it includes two brand new ear cushions, a noise canceling muff to go over the microphone, and another fuzzy protector that goes between your head and the metal frame of the headset. And it looks like it's black lamb's wool, something like that. And it's very comfortable. So all of those will be brand new. And that kit will be included. That cost me like $60. So you'll get that with the headset if you're interested. But this other one, I sold that about 2 days after I initially listed this stuff. So if you're interested, I wouldn't wait too long or it'll be gone too. I also have this really high quality Mutatoyo Pro 3600 digital protractor. Notice that it reads out in hundredths of a degree, and it's telling me the table it was sitting on when I took this picture was off by 0.23 degrees. It's extremely accurate, and I've used it mostly with my milling machine. When I wanted to mill something at an angle, I had a number of ways to clamp a piece down at the angle I wanted, but the only way to know for sure that that angle was right was to sit this protractor on top of the piece I planned to work on. And the other use for it would be during the setup of the pitch of your main rotor blades. When you're working on that linkage between the cyclic and the collective and the swash plate, you can set this down on the root of each blade and dial them in precisely. So those are two uses that I found very useful, and there was really no other way to do it that would be anywhere near as accurate as this. I also have a number of Aerospace connector pairs that are mated. Here you see a chassis mount connector on the bottom, which has got a D-shaped flat on the threads on the bottom. It goes into a D-shaped hole, so it won't rotate over time if that blue nut works its way loose a little bit. And then the mate is up on top. All Aerospace quality. This is the business end of the mate looking down. Every contact position has a letter designation, and if there are enough of them to run out of letters in the alphabet, they go from uppercase to lowercase. And some letters are missing because they could be misinterpreted. For example, there are no O's and Q's because they will look exactly the same unless you had a microscope. And they also leave out I. I think that may be the only three, but you'll get used to that. That's a standard in the aerospace industry. This is the connector on the Amphenol page, and I'll call your attention to two things. The arrow on the upper left is pointing to the part number, so you can Google that and you can find out everything you ever wanted to know about that chassis mount connector, and everything would apply to the mate pretty much, except the sex of the contacts and the fact that it's not chassis mount. The other side is a wire mount. Note the price of a new one is $112.31. So that mating pair I just showed you new would be over $200. But you're in luck, because my last job working for an aerospace contractor, they were moving from one building to another and they didn't have as much room. So they cleaned out a little storage room that they had for overstock. Over the years, you always buy more connectors than you need for a particular project. You can't use them again on another project. You can't sell connectors that one government agency paid for and resell them to another government agency. That wouldn't be good. So they just tucked them away in this room, and then when it was time to move, there was nowhere to put them, so they were hauling these things out by the truckload and throwing them in a dumpster. So I grabbed up what would be a lifetime supply for me, and good news for you. These are very high quality connectors. You can learn all about them and what makes these connectors perfect for aerospace by looking at the videos I put together under how-to videos. It's a 3-part series talking about how I do schematics and wiring and connectors. Here's 2 other things to look at. This is further down. That first shot I just showed you was the top of this particular page, but I couldn't fit it on the screen, so this is the bottom half of that same page. And it shows you that those connector pairs that I have quite a few of have 41 positions. So you could have up to 13 shielded twisted pairs that could go through those connectors end to end, including the shield, or 41 individual conductors. And then down at the bottom, it tells you that that particular contact size, which is the number 20, is rated at 7.5 amps. And so you need to keep that in mind when you're designing your electrical system. Next are these bus modules. These things are fantastic. I love them, and they're very expensive. I added up what I paid for this stuff, and you're looking at about $750 worth of parts just in those 2 little bins. I have 2 different types of bus modules, which I'll explain. And then on the left are DIN rails. These modules snap into position. So you mount the rail wherever you want these things using the holes in the bottom that you see, and then you snap them into position. And if you look at the bottom rail, you see AB, AB, A on the bottom side. Up on the top, you see 1, 2, and then nothing. And a dividing line that separates the A and B of one connector to the A and B of the next one. So if you had 5 modules in there, they would be 1A, 1B, 2A, 2B, and 3A. So that's a 5 module DIN rail. I also have 4s, 3s, and 2s, so they come in different lengths. The bus modules are very easy to snap into position, and they're really a pain in the neck to try and get out if you put them in the wrong way, in the wrong position. So bear that in mind. Now, how do we use them? What do we use them for? But I've got one more thing to show you before we get there. So again, this is a 1x20 module. There are 20 contact positions, and every one of them is bused together into one bus. So if you put 20 contacts with wires hanging out, all 20 of those wires would show continuity between each other. They'd all be connected together. Notice my red arrow again is pointing to the current limit for these 20 size contacts, and again it's 7.5 amps. So these aerospace parts are really well harmonized. They've been doing this for a long time, and these various components that are aerospace rated all play well together. Notice, however, that if you exceed 110,000 feet, you're going to have to derate the voltage. You can't put 1500 volts through there anymore. You got to go down to 200 volts. So if you're planning on flying your helicycle at or above 110,000 feet, bear that in mind. So here's how I use a couple of them. These are 1-20s or 20-1, however you want to specify them. All of these wires are connected together. So the bus module at the top was instrument plus 13 volts. So every instrument on the panel that required 13 volt power, all of those went onto this bus. And then I just have one wire that went back to plus 13. Saves running multiple wires all the way across the helicopter from one spot to another. You go, put this bus module on the upper panel near the indicators, and then you have short little wires that go down for plus and minus, and then one or two long ones depending on the total current drain to get you from the bus module to the plus 13 volts on the battery and the battery return, the negative. So that's how that works. And the reference designations for these, I use TB for, or B, what did I use? Yeah, TB, terminal bus, I guess is what I had in mind. And each one has a number and a letter, because the number and the letter, remember, are the location in the DIN rail. So TB2A would have been the third one. So there was a 1A and a 1B, and then the third one would be 2A. And then next to it was TB2B. So that would have been the fourth one on that DIN rail. So those are the ones that everything is all bused together into one bus. The other ones I have are 4x5s or 5x4, again, depending on how you're looking at it. So if you look, you can see that there are actually 5 separate buses on this little bitty thing. It's like a 1/2 inch by 3/4 of an inch, and that's about it. And each one has 4 contacts. So the arrows point to what I'm doing with positions A, B, C, and D, which are one separate, isolated little bus. And I've got tail rotor gearbox chip detector, main rotor gearbox chip detector. I've got the output going to the crew alerting system chip detector input. And then the other one, NC, stands for no connection. Sometimes I just leave unused contact positions open, but sometimes it's better to have a little line sticking out that says NC, because I can look at this very quickly and see that there's 4 unused positions. So I've got a little room for expansion depending what's going on. It's much easier than trying to trace the wires out and see which ones actually don't have any connections. That's much more difficult. So that's what I normally try and do with unused positions, is write N/C. Again, here's the sheet for that with the part number. You can look that up. And note the price. The reason I've got $750 in those 2 boxes is this thing is $29.81, and I've got like 25 of them. I don't know what I was thinking. but my loss can be your gain. So the bad news is these things are very expensive. The really bad news is you want to crimp the contacts. Well, you're going to need one of these tools. This is the Daniels Manufacturing Company crimp tool that will do those contacts. And this thing costs around $300 or so. And you can find them used for less than that, but they hold their value. So what I was thinking is no one's going to want to buy all of my bus terminals because you'll never use them. And you're not going to want to spend $300 for a crimp tool because you're not going to do that many crimps that require that size tool. So it occurred to me, I have the solution. You just send me a list of how long each wire needs to be coming out of one of these terminals. I'll crimp them on to the contacts, insert them into the bus terminal, and all you've got to do is snap it, mount the DIN rail, snap the little guys into position, and then terminate the far end of the wires to wherever they're going. Save yourself a lot of money. So if you're interested, let me know. I can't see all that well, but I can see well enough to do this. This would be pretty easy. If you've got the tools, it's simple. If you don't have the tools, you can't do it, period. Now we move on to a little higher current. I'd like to sell this whole box full of terminals. Starting on the right, I think those are for number 2, maybe number 4 wire, AWG. And then they get progressively smaller as you go right to left. For those great big ones, you need a pneumatic, or what am I saying? You need a hydraulic crimp tool. You can't crimp those things by hand. That requires too much force. I just happen to have the exact tool you need. It's a Chinese tool. The hydraulic crimper itself is great. Wonderful. Perfect tool. Works like a champ. The individual dies are pretty clunky, but they get the job done. And I didn't pay a whole lot for this tool. It was like, I don't know, 60 bucks or something. So if you're interested in taking this tool and those terminals off my hand as one lot, let me know. Sticking with the theme of high power, down at the bottom are 2 fuse holders for great big high amperage fuses, which are in the bag in the upper right. And I think you can probably Google that part number and you'll see what I'm talking about. That's the part number, and it looks like there's 4 pieces in that bag. I'm not sure all 4 are still there, but if you're interested, let me know. And then over on the left, those 2 bags, I've got red and white terminal caps, rubber caps, to insulate them so you don't short out a high amperage circuit and weld your screwdriver in there and you can't get it out and it turns white hot and the battery starts to catch on fire, and then after that it goes downhill. So I'd like to sell it. This is a little lot. These are good parts. I liked them. I used them. I've got a bunch of wire. This is a huge spool of custom wire that was created to Sikorsky helicopter specs. So this is a helicopter spec from Sikorsky. This is very, very high-tech wire. And I go into some detail in those how-to videos. At one point in the wiring video, I show you in detail. I compare this wire with the spool I'm going to show you in the next slide. So this is unusually high quality, very, very modern wire. It's very, very light, and it's very, very thin. And it was number 22 shielded twisted pair. And I think this is the exact same stuff, but it's a little bit older technology. This is insulated with Teflon tape. Same thing, shielded twisted pair. I think they're both 22. If you're interested, let me know. There's a lot on this one too, so you could do your whole helicycle with this spool. With the spool I just showed you, you could supply everybody building a helicycle and you'd have plenty left over. Here we have a selection. There's some 3-conductor shielded, that blue and white on the lower left for sure. There's some single conductor. The upper 2 on the left are single conductor 20 gauge. And I think the other 3 are shielded twisted pair. Maybe one of them's 3 conductor. So if you're interested, I'd like to sell these as a lot as well. And this would get you a long way. You wouldn't need a whole lot to do your helicycle if you had this stuff. Here's some welding cable. So for the battery, remember that the peak current, maybe remember is not the right word because you may not know this to start with, so you couldn't forget it. The peak current, when that when the starter is trying to spin up the engine, is 1200 amps. That's a lot of current, and you want to have a very low, it's called IR drop. You don't want the wire absorbing half of your power in the form of heat. You want big conductors that are very low loss. And this is welding cable. It's very flexible. It's pretty rugged. It's not aircraft, but it's plenty good enough. I used it on my helicycles. And the one in the middle is that's like number 8. But the red and the black, the big ones, are welding cable. Here's some more. This is aircraft spruce cable that I bought. And this is, I believe, number 4, most of it. There may be some number 2 in there. So if you're interested, let me know. Here's some nice number 8. This is good high quality stuff. And this is a good size for a lot of things. Back, around the engine, where you're not running this directly to the starter solenoid, but other things that require fairly heavy cable. Here's a bunch of mil-spec 50 ohm coax. I have a section on how to terminate 50 ohm coax with a BNC connector, and I talk about what kind of cable to look for. Most of this stuff is going to be silver plated copper, and I believe most of it has 2 shields instead of 1, so it's very high quality. This is what you want on your antenna transmission line. I already sold all the Adele clamps, the blue ones. They're all gone already. But I have a bunch of these little nylon clamps that you see holding that fuel line. And I wanted to show you how I use them. So this particular arrangement I use to run the fuel line all the way from under my seat pan, where the transducer was for fuel flow, all the way up to the engine fuel control. And this is how I did it. I've got all different sizes. You can see, I think I go from, well, you can look at your leisure, probably from like R2 to R20 at least. And you can look those up and see what the dimensions are. Quite a few in each bag. And I want to sell them all as one set or one lot. This would get you by. You wouldn't need any more. These little guys are really neat, and I'll show you how they're used as we go. So here's a side view of one. These are little bitty tie wrap mounts, and the tie wrap mount is in that center section that's elevated up off the surface, and it's just sitting there ready to be installed. The 2 legs on either side have sticky back foam tape, which is protected with protective layer of tape that you peel off. So what you do is you prepare the surface. In the case of sticking one onto your chromoly tube frame, I didn't want to epoxy these things down to powder coat. I wanted to epoxy them to steel. And so I made some little jigs so that I could protect the surrounding area of the powder coat when I got in there with my Dremel tool, and it didn't go skipping off across the powder coat and leave a big old nasty streak. So I'd get down there, clean out that hole till I was down to bare metal, clean it off with isopropyl alcohol, and then when I was all ready, and I would do like 5 or 6 of these at a time, then I would peel the backing tape off of the legs that you see, so they're all ready to go. And then you use a 2-part epoxy that comes in 2 different applicators. One of them is like 2 syringes side by side, and they mount in a tool. And you just snap this thing into position. It has a nozzle on the end of it that has a mixing chamber in it. So as the material comes out of the 2 Siamese sides of this dual applicator, they get swirled around and mixed together, and then they come out the tip on the end and they're all ready to go. You don't have to do anything. But if you're only doing, say, half a dozen, you don't want to spend a lot of money on multiple ounces of epoxy. Then you can get what looks like a little packet of tomato sauce from the Golden Arches, except it's got a partition in the middle, and the 2 halves of the epoxy are in there. So you just cut the end off this thing, squish all the material out onto something clean, mix it up with something else that's clean, like a little cough suppressor or whatever those little wooden things are that the doctor sticks in your mouth to keep your tongue down, tongue suppressors. Snap one of those in half or something. Use that to mix everything up, and then you've got a blob of epoxy about the size of a sugar cube, which is enough to do half a dozen of these things. So now you're ready. You put a little blob on the spot you've prepared. You've already pulled the backing tape off of this little guy. You line it up so that everything's in the right orientation. The slot in the tie wrap mount is pointed the right way, so the cable is going to go where you want it, and you don't find you've stuck it in there at right angles. Once you've got that oriented out, then you just press it down and you stick it down on either side, and now you're ready to go. You push on that piece on the middle, and if you look really closely, there's like a spring made out of plastic on either side. So as you push on this thing, it goes snap, and it snaps itself and squishes it down on the epoxy, and it holds it in position. That's it. Come back in an hour, grab hold of that thing, and just give it a twist, and it pops off, leaving the terminal. Everything else you throw in the trash can. Now I'm pointing to the end result. There's one of those little guys right there, and it's holding my thermocouple line going back to the engine's thermocouple. I forgot the name of the manufacturer, but if you're interested, let me know, and I can provide that for you. Here's some odds and ends. Those at the top are Honeywell aircraft switches. Those are the only switches I would recommend that you ever use on your Helicycle. Every airplane I've ever worked on, and I've spent 13 years maintaining airplanes for United Airlines, flying on airplane for NASA, supporting an airplane for the Air Force in Korea and another one for the Brits in England. All of those airplanes had Honeywell switches, every last one of them. Down below those three little green guys are circuit breakers. Those are the kind I suggest. If you want to buy this little lot, I'll sell them to you cheap. You can see why the Honeywell switches are good, and the same with these little clicks-on breakers. They're thermal compensated. So if you're out at Sun and Fun or something, and the helicopter's sitting out there in the bright sun in the summer, that canopy acts like a great big magnifying glass, and the sun just beats down on top of that instrument pod, and that gets so hot you can hardly touch it. And that will throw normal circuit breaker out of whack because they're not thermally compensated. These are. And then the last thing is a 10 amp dual DP/DT, dual position dual throw relay, which I use to feed power to the starter solenoid. Here's some more parts. These are not thermally compensated, but more circuit breakers. So if you don't want to listen to me and you don't care, you can use these. And there's a bunch of hardware there. I'll never use any of them. So, probably you're not going to call me and say, I've got to have those circuit breakers. But if you said, hey, I'd like to buy something like that Bose headset, how about throwing all that other stuff in, because nobody's going to want it anyway. And it doesn't look like it's worth a whole lot. So, what do you want? You're going to have to go down to the UPS anyway. How much more work would it be to put those in, get them out of your hair? I would be a receptive audience. I've also got helicoils. I've used a few, but not very many out of these kits. One of them's a number 8, the next one's a number 10, and the third one is a number 10 locking. So that's an unusual one. And the inside of the helicoils are coated with some sort of a rubberized material to keep the screws from vibrating loose over time. Here is some black stainless steel instrument mounting hardware. I didn't know there was such a thing as black stainless, but there they are. And here's what I'm talking about. So this is the last instrument panel I made. Those are my custom instruments that I sell, if you're interested. And they're mounted with these socket head cap screw black stainless screws. And the way I discovered that is I bought some that looked just like this from Granger's, and it turned out they were coated with black ink or some sort of paint or something, but they were just steel screws. And after a couple months, they all started to rust. And so I found out that my favorite screw company that sells nothing but fasteners said, the answer to your problem is black stainless steel. And I said, no kidding. And there they are. So if you want some of that, let me know. Here's a bunch of hardware for mounting your windscreen. Same deal here. I wouldn't get too excited about these little ones, but I don't need this stuff anymore. I don't want to throw it out. And so if you want something that is worth more money, like you want all those spools of wire I showed you earlier, and you say, how about throwing some of this stuff in? I'll give you $10 or something, let's work a deal. That'll be more room in my garage. These are Clecos, and that's a Cleco tool. If you don't know what Clecos are, it's because you're just starting out on building your kit, and you will soon find out. And if you're extremely wealthy and you want to stand out from the other guys at the helicopter meet, you might want one of these things. I'll warn you right now, this is an expensive tool. This does the equivalent of safety wiring, except you don't use regular safety wire. You use those little steel braided pieces that you see in the bag up there. They have um, a little nub on the end that's crimped on there. You stick this thing through your bolts, and then you slide it through the end of the tool. You start cranking on it. When it gets tight enough, I believe it cuts it off all by itself, but maybe there's another button. I haven't used this tool. I only used it probably 5 times since it was purchased. It's been sitting in its factory box ever since, and I don't remember how to use it, but the instructions are in the box, and you have 2 different length noses on this thing. The other one's on the right. So if you're getting into some place that you can't reach with the short one, you put the long one on the end. And this is what it looks like. So, oh, I forgot to mention. So once you get everything ready to go, then you take another little nub and you stick it in the end of that tool. There's a little spot where it goes. You feed the wire through the hole in the little nub, and then the tool tensions up the wire, crimps that nub on there, and cuts it off flush. And this is what you end up with. So it does a beautiful job. All of the other Helicycle guys will be jealous. They'll immediately want to know where you got that. And don't tell them. Keep them guessing. So it does a beautiful job. And unlike regular wire wrap, it doesn't leave a nasty sharp end out that you've got to worry about. Because if you don't curl that end up right, you're going to end up with bloody wrists sooner or later. But this tool is not cheap. If you're brave, there's the part number. You can look it up. And this again is Daniel Manufacturing Company. They only make super, super high quality aerospace tooling. So if it says DMC on it, it won't be cheap, but it's going to be very high quality stuff. If you don't want to go that route, there you go. I've got 2 sizes of safety wire that I've barely used, so this is a lifetime supply. Same deal, if you want something substantial and there's room in the box, you could talk me into throwing these in. And that's it. And then, because I did this, I wanted to share it with the Helicycle community. These are all the parts, not everything, but these are the ones that I had handy that I've used in the past. And there's the description of the part on column 1. Column 2 is the mill part number, if it has one, and 3 is the manufacturer part number. So here I've got those little indicator lights that I showed you earlier. Let's see, lamps for those little lights, DIN rails. There's the part number for those, which I did not mention, and there's the 1x12 bus module. I think that's a 1x20. I'll have to check again. And the 5x4 was the second one I showed you. So there's the part numbers. Module contacts. Solder preforms. I think I've discussed those in my wiring how-to stuff. You can see what those are about. And they come in different sizes, so you have to kind of be a little bit careful before you order. They're not cheap. They're like $1.50 a piece. Static port manifold is something I got from Aircraft Spruce, so you could take your static port, plumb that into this thing, and then it had about 4 outputs, so you could go to your VSI, your airspeed, and your blind altimeter for your transponder, all from this one manifold. And there's the hose fittings that I use for it. What else do we got? Angle fittings. So I use some straight and some angled. Oh, that's the stainless steel black hardware. I don't know if you'll find that part number, but good luck. It may be just this one supplier that has it, but you never know. And we have solid gold plated contacts for UMA D-sub connectors. So those would be female contacts. But if you buy instruments from me, they come with a mating connector and the contacts. So I don't know why I put those in there. You don't really need them because each connector, each instrument comes with a connector. Next pile, what do we got here? We've got these are the numbers for the Honeywell Aerospace switches. Single pole, single throw, double pole, double throw, double pole, single throw. There are many, many flavors. There are center off, spring loaded. There's ones that have a gate, so you can't get from one side to the other unless you lift up on the plunger and lift it over the gate and drop it down on the other side. There are a lot of different kinds, but that'll give you enough information to get into the Honeywell catalog and see what you've got and what you want. Switch guards, red switch guards. There's different flavors of those, so be careful. Some, when you snap it down, will turn the switch off. Some will turn it on. It all depends on where the little slot is in the switch and what kind of switch you've got, and so forth and so on. Here's those temperature compensated clicks on breakers. The only values I used were 1, 3, 5, 7.5, 10, and 15 amp. And there's all the part numbers for all of those. A SonoAlert is a solid state oral warning alarm, which I used for rotor redline. It's very, very loud. It's loud enough that you can hear it over all the noise in the helicopter with your noise canceling headset on. And the Helicycle is very quiet. It's not that noisy. Also, I've got a Hobbs hour meter, which I've got 2 of them actually to sell. They're very, very small. You can look up that part number and see what the dimensions are. They're really slick. And then there's DIN rails, the 5-position. From that, you can probably find 4, 3, and 2s. But again, I've got those here. And bus rails, seem like I just went through that once, but here it is again. And ring terminals, I talk about those in great detail in one of my how-to videos. Amp, P, D, I, G are the only ring terminals that I would ever use on an aircraft, period. Exclamation point. And more solder preforms. I'm probably repeating myself a little bit on this one. I think this is the last one. So these are Deutsch connectors. These are automotive connectors, but they're pretty high quality. I like them. They don't have a lot of contacts. What do we got? 4, 6, 4, 6, 4. You have to look them up. And they use solid machine contacts. They're not gold plated, which is aerospace quality, but they're nickel plated, which is good enough for what we're doing. And then there's let's see, there's just more Deutsch connectors all the way to the bottom almost. And then we've got 2-pin plugs. You'll just have to look those up. I forgot what all that stuff is. One more. What do we got here? Oh, this is big stuff. So the batteries I used were 2 Odyssey PC 680s. And the next one are brackets. You get 2 of those. I think they're sold separately. And they come together like 2 clamshells, and they will enclose 2 PC 680 batteries and hold them in position. and that dual stack will fit nicely between the upper frame rails right behind the fuel tank if you're light. If you're heavy, you're going to have to move the batteries back towards the tail for balance. What else we got? Oh, the master switch. This is a nice one I like. It's made by Blue Sea Systems. It's a marine switch. But the nice thing about it is it's rated at 1200 amps for 2.5 seconds. And that's pretty much what your starter is going to require for about that length of time while it's spinning the engine up. So this thing is actually designed to take that kind of load for that length of time. It's a very nice looking switch, and it's very high quality. Starter relay, 30 amp. Maybe that's the one I showed you. I don't remember. Made by Tyco. This ultra capacitor, it takes some explaining. I get nervous with this stuff down below, the diode. All of that stuff has to do with the fact that there's internal resistance in the battery, and when it's seeing a 1200 amp load initially, the battery voltage goes down to about 8 volts. So it's sitting at 13, let's say. You hit that starter button, it drops down to 8 volts. Well, things like the igniter and fuel pumps, things like that, they don't like 8 volts. They don't work very well. And so I have a system that I use that isolates the essential bus from the battery when that starter is engaged. But if you do that stuff wrong, it could get you killed, or the engine could flame out in flight, that sort of thing. So I don't like getting too deeply into suggesting you do what I did, because if it goes sideways, I don't want to worry that I had something to do with your major accident. But those are the parts I used. So that, I think, is the last slide. That's it. So there's my email address if you have any questions or you want to tell me to stop doing these videos and shut up. And those are my 4 favorite electronic supply places, probably in order. I like DigiKey. At least at the time I was actively involved, which was a while ago. They had, I think they had a minimum order of $25 or something. So they catered to hobbyists, or at least they were, it's a major supply house. They've got everything. But let's say they were friendly to hobbyists. Mauser, pretty much the same quality. One of them has a parametric search tool, which is very, very handy. And I don't remember, I think it might be DigiKey. And so you can start entering all of the specs of what you're looking for, and it will slowly refine the suggestions it gives you until you have a very, very narrow list of things that match all of your criteria. Very useful. And then when you get to Newark and Allied, they're more, I think, industrial. They all have all the stuff. It's all good, no problem. But at least in the day, they required, I think, a bigger order. They didn't want any little $25 orders. But they're all good. One last word of warning. In that 6-part video series that BJ has that leads you through the construction, he talks about using acid core solder. He didn't know what he was talking about. He may have been an aviation genius designer, but he didn't know anything about electronics or soldering. He knew about repiping his house with copper and soldering the copper water pipe with acid core solder. But you do not do that with electronics. You'll rot everything out. Don't do it. Any one of these 4 suppliers can get you the kind of rosin core solder you need. If it's on their site, it's good stuff. There wouldn't be anything you could buy that would get you in trouble. So that's it. Sorry I talked too much, but I think this is my last one. So thanks for watching.